Parchin is a name that appears in the history of the Iranian nuclear program, the way a recurring symptom appears in a medical record, evidence of something difficult to explain any other way. For 2 decades, the military complex southeast of Tehran was the subject of IAEA inspection requests, diplomatic exchanges, and satellite imagery debates whose inconclusive surface-level findings had consumed the attention that subsurface construction required to proceed uncharacterized. What the target folder described was not the surface. It was what had been built below it during those years, and what had been built was the reason the targeting decision was made at a level of the command structure that does not communicate its reasoning through any channel that produces a documentary record. The facility was not a production site. Iran did not, at the time of the targeting decision, possess assembled tactical nuclear devices. The collection had established this with the confidence that requires years of multi-source corroboration, and that, when achieved, is more certain than most things the intelligence community is asked to be certain about. What the facility housed was the component category that precedes assembly, the non-nuclear components of a nuclear weapon system, whose characteristics are specific enough that their presence in combination constitutes, in the technical judgment of the analysts who characterize them, an advanced weapons development program rather than a civilian research activity. High explosive lenses whose geometry matched the implosion configurations of weapons design. Neutron initiator assemblies. Firing control systems whose parameters were inconsistent with any non-weapons application. Environmental conditioning infrastructure whose specifications matched the storage requirements of components that could not tolerate the temperature and humidity variations that uncontrolled underground environments produce. The components were not a weapon. They were a weapon's immediate predecessor, precision-engineered parts that, combined with fissile material produced at other facilities, would constitute a functional device within a timeline measured in days, not months, not years. The distinction was the reason the targeting decision was made when it was made. The depth was 63 meters, the deepest aim point in the entire series, a number that reflected the specific value the Iranian program had assigned to what was inside the chambers, and the specific calculation the facility's designers had made about what depth would protect it. 63 meters in the granite basement of the Alborz foothills southeast of Tehran, the same granite formation that the Alborz command node mission had encountered in a different location, consistent in density and hardness with the earlier mission's geological characterization, but deeper by 21 meters than that mission's aim point. 21 additional meters of dense granite. The weapons engineers who worked the fusing solution had approached the depth challenge with the modified sequential employment concept that had been developed for deep targets in the series. 2 weapons at the same aim point, the first opening a penetration channel through the upper formation, the second following the channel to a greater depth than either could achieve alone. The solution's confidence assessment was 82%, 18% acknowledged. The mission was authorized. The additional complexity that the Parchin facility introduced to the employment solution was not geological. It was mechanical. The non-nuclear components inside the chambers included high explosive lens assemblies, precision-machined explosive elements whose detonation in a confined space would produce an energy release that the kill mechanism analysis had to characterize and account for. Unlike the ferromagnetic compound reactions of the Yaz mission, which had produced additional seismic energy without complicating the weapon's employment geometry, the high explosive lens assemblies would produce a secondary detonation event that could alter the seismic environment inside the granite formation in ways that affected the second weapon's terminal guidance if the interval between the two weapons was too short. The structural engineers computed a minimum interval of 93 seconds between the first detonation and the second weapon's arrival. 93 seconds to allow the high explosive secondary detonation's seismic disturbance to decay to a level that did not introduce terminal guidance error in the second weapon's GPS solution. 93 seconds. The coordination geometry for a two-aircraft package required 93 seconds of separation between the first aircraft's weapon impact and the second aircraft's weapon release, a constraint that produced a trail interval, computed against the aircraft's approach speed and the distance to the initial point of 1 minute and 47 seconds between the two aircraft's initial point crossings. 1 minute and 47 seconds from a coordinated pair whose position separation throughout the 14-hour flight had to be maintained within the precision the trail interval demanded. The two B-2 Spirits lifted off at 10:03 p.m. and 10:05 p.m., a 2-minute departure interval shorter than the standard 8 minutes. The shorter interval was deliberate. The 93-second trail constraint required continuous coordination, monitoring from the first minute of the sortie, which the 2-minute departure's shared data link range enabled. The mission commander of the lead aircraft tracked the separation and made 14 airspeed corrections over 14 hours. The largest was 4.1 knots. The trail interval was within tolerance at the final checkpoint, 2 hours before the initial points. The Parchin defense architecture was the densest in the entire series. Tehran's strategic umbrella extended to the Alborz foothills with S-300 PMU-2 batteries, a Bavar 373 covering Parchin approach sectors, 2 Tor M1 batteries on the perimeter, and a Pantsir S1 at the surface access compound. Additionally, unlike any previous target, the complex sat within range of the Tehran metropolitan area's own point defense coverage, whose engagement envelopes extended into the southern and eastern approach corridors, creating a defense in depth whose innermost layer exceeded the outer ring of any previous target. The EW architecture was the most comprehensive in the series. 4 EA-18G Growler flights from 2 carrier groups, coordinated through a protocol developed and rehearsed over 8 weeks, plus 2 land-based assets from partner facilities, providing inner ring and point defense suppression from different geometric angles simultaneously. 6 EW elements, sized against the one defense architecture in the series that justified 6. The EW package activated at 7:41 a.m. local time, 49 minutes before the planned first initial point. The activation covered all 6 threat systems simultaneously, the same simultaneous approach that the JASC mission had used against a simpler architecture, applied here against the full complexity of the Tehran strategic defense umbrella. The Iranian response was immediate and sophisticated. The S-300 PMU-2 batteries began frequency cycling within 45 seconds of activation, faster than any long-range system in the series had cycled. The Bavar 373 followed at 51 seconds. Both long-range systems were cycling at rates that compressed the Growler response windows to margins that the EW officers were managing at the edge of their pre-mission rehearsal parameters. The compression was expected. The architecture had been rehearsed against exactly this cycling rate. The rehearsals had produced the response protocols that the EW officers were executing. The protocols held. The inner ring's response was different from the long-range systems. The Tor M1 batteries did not cycle. They went silent. Both batteries ceased emitting at 7:42 a.m., 1 minute after the EW activation, and remained silent, their operators executing an emissions control protocol that preserved their detection capability from the passive characterization that active emissions produced. Silent TOR-M. 1 batteries were not suppressed, TOR-M1 batteries. Silent batteries could activate at any moment on any frequency, without the advance warning that active emissions provided to the EW architecture. The mission commander noted the silence at 7:43 a.m. when the passive warning receiver showed both inner ring TOR-M1 emissions cease. Silent inner ring systems were a contingency the planning had addressed. If both TOR-M1 batteries went to emissions control, the land-based EW assets would shift from targeted frequency suppression to broadband coverage of the TOR-M1 frequency range, less efficient, more power-intensive, but capable of suppressing a system that activated on any frequency within the range. The shift required 14 seconds to reach effectiveness. 14 seconds of potential TOR-M1 free operation at any moment of their choosing. The lead aircraft entered the inner defense ring at 8:19 a.m. The TOR-M1 batteries remained silent. The mission commander watched the passive warning receiver. The batteries had been silent for 37 minutes. An emissions control posture maintained for 37 minutes was either a standing protocol or a reaction to the EW environment that the operators intended to maintain until they had a reason to break it. They would have a reason to break it when their engagement controller authorized activation, an authorization that required a contact report, which required a detection, which required an active emission. Silence protected them from characterization. It also prevented them from generating the detection that would end the silence. The silence and the protection were the same condition. At 8:21 a.m., 11 minutes and 34 seconds from the first initial point, the Pantsir S-1 at the facility's surface access compound activated, not in search mode, in fire control mode. The emissions signature was unambiguous. The Pantsir's fire control radar produced a specific waveform. The passive receiver classified immediately. Fire control mode without a prior search mode activation meant the Pantsir had been given a contact from an external source. It was not searching. It was tracking. Something in the defense architecture had generated a track and cued the Pantsir directly to fire control without requiring it to find the contact itself. The mission commander assessed the cuing source in the time available. The long-range systems were jammed and cycling, producing no clean tracks. The inner ring TOR-M1 batteries were silent. No emissions, no tracks. The Pantsir was in fire control. The cuing source was not any of the characterized systems. It was something else. The cuing source was the Tehran metropolitan area's own point defense coverage, a system whose engagement envelope the approach corridor had been designed to avoid, which had generated a marginal detection at its envelope edge, below the Tehran system's own engagement threshold. Above the data fusion forwarding threshold applied to contacts passed as cuing data to dependent systems. The Pantsir was within its coverage zone. It received the cuing data and activated fire control to attempt independent confirmation. The land-based EW asset assigned to the Pantsir's suppression had been covering the Pantsir in broadband mode since the TOR-M1 emissions control posture had shifted the allocation to broadband coverage. Broadband coverage included the Pantsir's fire control frequency band. The Pantsir's fire control activation was met with suppression within 3 seconds. 3 seconds of unsuppressed fire control operation had produced one sweep. The sweep returned a contact at 29% detection confidence. The cuing data had placed the fire control radar's search window in the correct area, but 29% was below the Pantsir's autonomous engagement threshold. The operator transmitted a contact report. 29%, bearing northwest, fire control confirmation partial. The base defense controller received the report at 8:21 a.m. and 47 seconds. The base defense controller now had a cuing contact from the Tehran system, a 29% Pantsir fire control return, and 2 silent Tor-M1 batteries that had been in emissions control for 40 minutes. He authorized Tor-M1 activation at 8:21 a.m. and 53 seconds, one of the 2 batteries, the eastern one, on the frequency that the emissions control posture had been preserving. The eastern Tor-M1 activated on its preserved frequency at 8:22 a.m. The land-based EW assets broadband coverage had been allocated across the Tor-M1 frequency range. The specific frequency the eastern battery had chosen was within the broadband coverage. The coverage was not precision targeted. It was distributed across the range, which meant the suppression effectiveness at any single frequency within the range was lower than the pre-targeted suppression the earlier missions had used against characterized emissions. 67% suppression on the Tor-M1's activated frequency. 67% left 33% of the system's acquisition capability functional. 33% capability operating with a cuing input from the Pantsir's contact report and the Tehran forwarded data produced an acquisition return at 8:22 a.m. and 14 seconds, 38% detection confidence. The integrated data fusion at the base defense controller's console received the Tor-M1 return at 8:22 a.m. and 18 seconds and combined it with the Pantsir's 29% return from 37 seconds earlier. 2 systems, same bearing, returns at 29 and 38%, integration algorithm producing a fused confidence assessment of 51%, above the base defense alert threshold of 45%. The defense controller transmitted an engagement authorization at 8:22 a.m. and 24 seconds. The eastern Tor-M1 launched 2 missiles at 8:22 a.m. and 31 seconds. The mission commander saw the uplink signatures activate at 8:22 a.m. and 32 seconds, 1 second after launch, 9 minutes and 2 seconds to the first initial point. He ran the intercept geometry. Tor-M1 fire control return at 33% effectiveness, single sweep, range ambiguous. The solution bracket was wider than the Tor-M1's optimal engagement would have produced. The B-2s' actual position was inside the bracket. The lethal radius distribution across the bracket's range ambiguity envelope placed the most probable detonation point at the bracket's center, with the lethal radius cone narrowing toward the bracket's edges. Whether the aircraft was inside the lethal radius depended on where inside the bracket it actually was, a function of the range error in the imprecise fire control solution. He did not hold course because he was comfortable with the geometry. He held course because the initial point was 9 minutes away, and turning would cost the mission. The Growler EW officer had the Tor-M1 uplink frequency active on his monitoring display within 2 seconds of the launch. He redirected maximum output to the uplink band at 8:22 a.m. and 34 seconds, 3 seconds after launch. The uplink degraded. The missiles flew on their last computed trajectory. Both detonated at 8:23 a.m. and 9 seconds, 38 seconds after launch. The range ambiguity in the fire control solution had placed the computed intercept point at the bracket center. The aircraft's actual position, determined by the range error in the 33% effectiveness acquisition data, was 840 meters from the bracket center, outside the lethal radius at that offset. Both detonations occurred 840 meters behind the aircraft's actual position. The pressure signatures reached the airframe as the vibration that had become a reference point in the series. Near miss, confirmed non-lethal, mission continuing. The base defense controller transmitted a regional escalation request at 8:23 a.m. and 47 seconds. The mission commander noted it in the intelligence feed and computed the regional response timeline against the remaining flight time to the initial point. 9 minutes to the first initial point, 93 seconds of post-impact waiting time, then the trail aircraft's initial point, then the egress. Total window to completion, approximately 11 minutes and 30 seconds. Regional response timeline against an adversary system required a minimum of 18 minutes from escalation's request to engagement capability for any system not already in the sector. 11 minutes and 30 seconds inside an 18-minute response window. He continued. The first initial point was at 8:30 a.m. and 11 seconds. The bay doors opened with the structural shudder that 16 years had not made unremarkable. The first GBU-57 released. The aircraft corrected and turned toward the post-release heading. Bay doors closed. The weapon's descent through the Alborz foothill granite proceeded without the microfracturing variability that had characterized the Noye mission or the density anomalies that had affected previous granite targets. The Parchin granite was consistent with the Alborz command node mission's characterization. Dense, uniform, predictable. The fusing algorithm ran its sequence against a deceleration profile that matched the model at every depth. The first weapon detonated at 31 meters, the design depth for the penetration channel opening, not the facility's chambers. The detonation established the fracture channel through the upper granite formation with the geometry the sequential employment solution required. The high explosive lens assemblies inside the chambers responded to the seismic energy transmitted through 63 meters of granite above them at 8:30 a.m. and 49 seconds, 31 seconds after the first detonation. The secondary detonation from the lens assemblies was not a nuclear event. It was a high explosive event of the scale that the kill mechanism analysis had computed for the stored inventory. The combined seismic signature reached the surface at 8:30 a.m. and 51 seconds as a 2.3 magnitude event. Monitoring stations across the Tehran region registered it simultaneously. The Parchin base's internal monitoring systems registered it as a seismic event at the facility coordinates. Not in the upper formation where the weapon had detonated, but deeper, where the lens assemblies were located. The monitoring system's depth estimate placed the secondary event at 62 meters, 1 meter above the facility's chambers. The trail aircraft's initial point was at 8:31 a.m. and 58 seconds, 93 seconds after the first weapon's surface impact, 22 seconds after the secondary detonation's seismic disturbance had decayed to the level the structural engineers had computed as safe for second weapon GPS solution integrity. The second GBU-57 released. It followed the penetration channel the first weapon had opened through the upper granite, its terminal guidance computing continuous corrections as it descended through the fractured formation. The channel guided it to a depth that the first weapon's detonation and the secondary high explosive event had combined to reach 59 meters of effective penetration in dense granite, following a fracture channel whose geometry had been established by the first weapon and extended by the secondary event's additional energy. The fuse threshold at 59 meters, 4 meters above the facility's 63-meter chambers, placed the second detonation at a position in the fractured rock column above the chambers whose overpressure transmission characteristic was not the same as undamaged granite. The fractured column transmitted the second detonation's energy into the chambers with the efficiency that fractured rock provides compared to intact rock. Higher transmission coefficient, lower absorption. The combined loading from the first weapon, the secondary high explosive event, and the second weapon's transmitted overpressure exceeded the structural tolerance of the chamber infrastructure. The chambers and their contents were eliminated at 8:32 a.m. and 18 seconds. The third seismic event that reached the regional monitoring network at 8:32 a.m. was the second weapon's detonation at 59 meters, producing a 2.1 magnitude signature that followed the 2.3 magnitude secondary event by 93 seconds and the 1.9 magnitude first weapon signature by 1 minute and 49 seconds. Three events, 93 and 109 seconds apart, at the same geographic coordinate, at depths of 31, 62, and 59 meters respectively. No natural seismic sequence produces three events of similar magnitude at the same coordinate with those depth and timing characteristics. The duty seismologist at the Tehran Seismic Monitoring Center filed his anomaly report at 8:41 a.m. The Parchin base commander, who had been managing an active engagement situation, a regional escalation request, and two silent TOR-M1 batteries since 8:21 a.m., received the seismic report at 8:43 a.m. and understood immediately that the facility contact loss, the loss of communication with the underground complex that the base's monitoring system had registered at 8:32 a.m., was not a power outage. He transmitted his comprehensive situation report at 8:47 a.m. Both B-2s were 210 miles into their respective egress headings, the numbers that closed the package. 14 hours and 3 minutes of flight time for the lead aircraft. Two GBU-57 massive ordnance penetrators employed in a 93-second interval, constrained by high-explosive secondary detonation seismic clearance requirements. Two silent TOR-M, one batteries in emissions control for 40 minutes, a posture that prevented characterization while preventing detection simultaneously. One cuing contact from the Tehran metropolitan point defense coverage at its engagement envelope margin, below the Tehran system's engagement threshold, above the data fusion forwarding threshold. Fused contact confidence of 51% from a 29% Pantsir return, and 38% TOR-M, one return triggering engagement authorization. Two TOR-M1 missiles on a 33% effectiveness fire control solution, both detonated 840 meters from the aircraft's actual position. Three seismic events in 109 seconds at the same coordinate. Zero aircraft lost. Primary chambers eliminated. The non-nuclear component inventory, whose characteristics the collection had assessed as an advanced weapons development program, the high-explosive lens assemblies, the neutron initiator components, the firing control systems, the precision-conditioned storage environment that maintain them within operational tolerances, ceased to exist as a coherent weapons development asset at 8:32 a.m. The fissile material that would have been combined with these components remains elsewhere, waiting for a component set that no longer exists in the form it existed this morning. The timeline that existed before 8:30 a.m. does not exist after 8:32 a.m. The rubble is evidence. The timeline is the outcome. The Alborz granite holds its depth and its silence. What the depth was protecting no longer requires protection.